So the subject of the lesson that we've been working on is trying to understand how topography, or the changes in elevation of the natural land, how that will make water flow on the land surface and underground. And topography, being the change in natural landscape, should give us a clue as to how that's going to happen, because we know that groundwater, just as surface water does, is going to flow from high elevations to low elevations. In real people terms, that means downhill. But you have to know where the downhill is and where the uphill is, so that you can determine how streams and rivers are flowing and what that means for the natural life and the people who live up and downstream from that river. So let's take a look at a practical example that we did in class. We start the activity with a little handheld landscape, and this one kind of looks like a volcano. Well, it should, because it is a volcano. I'll tip it over so you can see a little bit more of the detail. Not very large. Now, through the magic of television, I'm going to put this in a bin, and I'm going to put some markings on it, and I'll tell you what we're going to do after that. Voila, you have magic. Now, the landscape is inside a Tupperware bin that has some markings on the side. Each long marking is 1 full centimeter. Each smaller marking in between is a half centimeter. Now, I took a photo of this landscape and we used that as a note page to gather what we're going to do next. So I'm going to take some water and I'm going to fill it up to one of these lines, and we're going to see what it looks like inside the landscape. So we start by adding enough water to bring the water level up to the 3rd centimeter that's written on the side of the bin. Now, just coincidentally, that happens to be about 500 milliliters of water. So I'm going to pour it in, and if your landscape starts to float, it is made of plastic. That's all right. I'll show you how to make sure that that doesn't really make that big of a deal. Now, that's 1.5 centimeters, so I'm going to need a little bit more water, and then we'll see what it looks like. All right, that is 3 centimeters of water in the bottom of the landscape. Now, if your landscape does decide it wants to float a little bit, all you got to do is press it down. That will evacuate some air through the caldera, and that should equal out the densities and the pressures and all that, and your plastic landscape will sit just fine. But you notice where the water line is around the entire landscape. We're going to take the piece of paper that looks pretty similar to this, and what you're going to do is you're going to trace exactly on your paper where the water line stopped on the landscape. And then, after you do that, you're going to add a half centimeter of water and stop and trace that water line again. So that's 3.5 centimeters, and you can see that the water line left behind looks a little different. Well, you're going to do that for every half centimeter all the way up to 5 centimeters and draw what the water left behind on the landscape. So here's the paper that I am using. It's actually a picture that I took of the landscape and I photocopied it, so now it's just a flat piece of paper. And what I'll do is every time I make a new water line, I'm going to make a new mark on my paper and trace that water line. So I will do that for 3 centimeters, 3.5, 4, 4.5, and then 5. And this is what it looks like if you do exactly that for every line of elevation change of water on your landscape. Alright, so all of these lines represent a half centimeter of elevation gained every time you poured water on the landscape. Now, something that's really important to know is, what are these lines really telling us? Well, for every mark that you make, like the very first one is on the far outside of your landscape, everywhere exactly on that line is exactly 3 centimeters of elevation. So anything above that line or closer to the caldera is higher than 3 centimeters, and everything on the outside of that line or farther away from the caldera is lower than 3 centimeters. And so on until you get all the way to that one line that's very close to the caldera itself. That line is exactly 5 centimeters of increased water. So anything away from the caldera is less than 5 centimeters. Anything closer than that line to the caldera is more than 5 centimeters of elevation. So here's a question. Just by looking at this picture, how can you tell, let the lines be your guide, how can you tell which areas of the volcano have a steeper slope and which have a gradual slope?